In this tutorial, we're going to walk through how to use LYNEports to analyze locations and plan for aviation infrastructure using AI. First, click on the LYNEports AI tab. Then, type the location you want to analyze. For this example, we'll use Orlando. Let's choose a site near an airport that already has some infrastructure. The goal is to select a location that requires minimal modifications and offers a high ROI. LYNEports AI will then provide you with a site based on the parameters you've set, and it can also suggest other locations while showing you whether they're feasible. To validate, you can click on the Measure Distance button in the top left corner of the tool menu and check how far the selected site is from the runway and nearby streets. This allows you to assess that the AI-chosen location follows FAA regulations and keeps the aircraft at a safe distance from both the runway and surrounding roads. Now, I've opened a project created at Walt Disney. For this example, we'll upload data directly by adding the digital obstacle files from the FAA website. First, download the relevant file, for example, California. Then, click the Geospatial Library button in the left toolbar and import the file into your project. LYNEports supports multiple formats, including CSV, KML, and GeoJSON. Once the data is imported, hover over any item to view details such as obstacles, verification status, and the date of the last FAA update. This allows you to understand the environment and ensures your project data is accurate and up to date. Now let's explore the AI features. For example, you can create a landing pad for a specific aircraft, whether it's an eVTOL, a helicopter, or a traditional fixed-wing aircraft. The AI aligns the design with regulations and generates a 3D model for the selected area. If you'd like to modify the output, you can adjust the 3D model in real time. Next, let's create obstacle limitation surfaces to identify and avoid obstacles in the area, ensuring they're suitable for the type of aircraft you've selected. LYNEports can also highlight any potential conflicts. If a surface intersects an obstacle, it will turn red, showing you immediately if there are any obstacles in that direction. Now let's create TERPs using LYNEports AI. We'll ask the AI to generate a flight path that aligns with the north side of the obstacle limitation surface. Within seconds, LYNEports produces a smooth, optimized route that follows the parameters you've set. Once the path is created, you can easily customize it if needed. You can adjust the direction of the points, change the color of the route, or make any other modifications. It's intuitive and highly flexible, allowing you to test different flight paths and instantly see how they fit within your OLS. With LYNEports, you can easily analyze, design, and validate aviation sites, all within a single platform. This makes LYNEports a powerful tool for early-stage planning and site assessments.